Hello everyone, before we start the lesson, let's try this warm-up. What rules could be followed in these functions? Remember, a function has an input and an output. Now, I've strung two functions together. When I input 10 into the first one, its output is now the input of the second machine, and the output of that one is 45. So I want you to come up with a rule for the first machine and a rule for the second machine so that when I put 10 as the input in the first machine, we get 45 as the output of the second machine. So pause the video, see what you can come up with. Here's one you might have come up with, or maybe you came up with this one. Maybe even this one. There's lots of options. You might have come up with two different rules that work. Who knows? If you're not sure, check with me before you move on. We're going to continue the theme of functions. In the last lesson, we looked at what a function is. Now we're going to focus more on functions represented as a table of values. And we're going to distinguish between tables that represent functions and tables that don't represent functions. So we're going to call that functions and non-functions. Let's start just with a reminder about functions represented as tables. We have input, we have output. For each input, we follow a rule. The rule tells us what the output is. For this input-output table, the rule is the number of letters in the input. So when the input is the word fill, well, there's 4 letters, so the output is 4. The word math has 4 letters, so the output is 4. California, 10 letters. Math, well, we already did that one. Still has 4 letters. So this tells us that this table represents a function. This is a function table because for each input, there's exactly one output. Doesn't matter how many times I put the word math into the function, I get the same output every time. So because each input has exactly one output, we know this is a function. So here's another example. Are these function tables? How can you tell? Take a minute to think. If I look at the first one, each input has only one output, so that gets a check. That is a function table. If I look at the second one, though, look carefully. Input 5, 2 different outputs. So for the same input, we get different outputs. Because each input doesn't have exactly one output, this is not a function table. So just remember, a table is not a function table if an input has at least 2 different outputs. So what I'd like you to do is answer the question, is the table a function table? You've got 6 different tables here. I'd like you to answer that question for each of them. So pause the video and determine whether each table is a function table or not. Well, here you go. For the first one, each input is different, and each input has only one output, so that's good. The second one, I've highlighted it here, input of 3, but you get either 7 or 3 as the output, so that's not a function because you get more than one output for one input. The third table is okay. Each input has one output. Even if the outputs are the same for different inputs, that's fine. You have to look at, for each input, how many outputs do you get? So this one's okay. Each input has only one output. The next one, also good. Part E, input 4, output -5. Input 4, output 2. Different outputs for the same input, not a function. Here you might have got tricked with the last one. But just remember 5 squared is 25, so these are actually the same output for the one input. So this is a function because there's only one output for each input. If any of that was confusing, please reach out before you move on to the rest of the lesson. Sometimes the output is given and we need to find the input. And to do this, we need to do what we call inverse operations. So here's an example. We don't know what the input is. We know the rule of the function is times 3, and we know the output was 6. So working backwards, doing the inverse operation, we can figure out what the input is. So of course, the inverse of times 3 is divide by 3. Those are opposite operations. So if we take the output and divide by 3, we will work backwards to get what the input was, in this case, 2. And you can always check your answer. 2 times 3 is 6, so it worked out. So try these ones on your own. Fill in the input for the function machine. You know the rule, you know the output, so work backwards, use inverse operations to find what the input was. Pause the video and try this on your own, and then check back in to see how you did. Here's the answers. The opposite of multiplying is dividing, so 12 divided by 4 is 3. The opposite of adding is subtracting, so 12 minus 4 is 8. Here it's subtract 2, so going backwards we add 2. Divide by 2, the opposite is times 2. Multiplying by a negative, well, the inverse would be dividing by that negative. So negative 6 divided by negative 2 is positive 3. And the last one, it will be 5 multiplied by negative 3, which gets us negative 15. You might have got tripped up with the negative signs, but you're still working at opposite operations or inverse operations to find the input. Here's a slightly more difficult question. This time you have an input-output table or a table of values. And I want you to figure out what the function rule is based on the inputs and outputs that you know, and then fill in the function table. So there's two parts to this question. Find the rule, and then fill in the table. So try that for each of these. Pause the video, try it, and then check back in. Well, here we are. Now, you might have been able to fill in the outputs without figuring out what the rule was necessarily. And you might have done that just by looking at patterns. For example, 5, 6, 7, you might have just seen, well, you're just adding 1 to the output every time. And you would have got these answers, but that's not what I'm asking for. The function rule is, what do you do to the input to get the output? So for the first one, the rule is actually add 4. 1 plus 4 gets you 5. 2 plus 4 gets you 6. 3 plus 4 is 7. 4 plus 4, 8. 5 plus 4, 9. 6 plus 4 is 10. So the rule is add 4. Likewise, for the second and third ones, you might have been looking at patterns in the output to find the rest of the output values. However, to find the rule, you want to think about, what are you doing to the input to get the output? So that's where these rules came from, and if you're struggling with that, this is where you should be pausing the video and reaching out for help before you move on to the rest of the lesson. But if you're okay with that, try these ones now, and it's the same question. Find the rule. What are you doing to the input to get the output? And then complete the table. So pause the video and try these ones. Well, here we are. Subtract 3 is the rule for the first function. If you subtract 3 from the input, you get these values. The next one, multiply by negative 0.5 or negative 1/2. And the third one, you might have had trouble with that. That's why I called it a bonus, just to see if you could figure it out. It's the number of consonants in the input. So if you look at the word one, well, there's 3 letters, but 2 of them are vowels, so there's 1 consonant. In the word two, there's 2 consonants, etc. So remember, we're looking at tables and determining whether or not the table represents a function. A function has only 1 output for each input. Keep that idea in your mind as you practice.